All right, on tonight's episode of Python Papi, we're back inside our generative AI course, and we're still going over vector databases. Let's have a look at what we went over tonight. Now, yesterday, if you recall, the last thing we went over inside the vector database was the embeddings, or we started going over a simplified explanation of embeddings. And tonight, we're going to pick up where we left off. So, I believe last night we went over the vocabulary last night. As you can see here, we had an example vocabulary: king, queen, man, woman, lion. Now, from this vocabulary, we can extract our features. This is our feature list. We have gender, wealth, power, weight, and speak. Now, this vocabulary and its features will be handled by the neural network. The vocabulary will get passed into the neural network, and the neural network will automatically look into the features or produce the features for us. So we will create our data in such a way that we will have a vocabulary in the neural network. We will be passing our vocabulary to the neural network, and the features will be created. In between this, we will generate a vector. The vector itself will be our embedding. Now, this is a high level representation of what our vector will look like. Whatever complex mathematics we get from our vocabulary, neural network, and features, this is a high representation of that. Now, let's look at our example vocabulary and feature list again. This time we will assign a weight to our vocabulary elements. The weights will be between 0 and 1. Now let's add the values to our elements. So we're going to be using the same example vocabulary we had with the king, queen, man, woman, and lion. And we're going to use the same feature list: gender, wealth, power, weight, and speak. And this time we're going to assign the gender as male. As you can see here, this way to be easier to add weights to our vocabulary. So we have our vectors. The king and his values are the first vector. So this is our first vector here. And you can see here we have a weight assigned between 0 and 1 for every feature in our feature list. So we have 1 for male because he is male, 1 for wealth because the king is wealthy. We have 1 for power because the king is powerful. We have 1 for weight, we have a 0.8 for weight, and we have a 1 for speak because yes, the king can speak. Then you can see here for our queen, we have a 0 because she's not a man, 1 because she is wealthy. Weight or power, she has a 0.8. She has power, but not as much as the king. And I don't know why they instruct that 0.9 for weight. His queen outweighs him, I guess. So let's change that there to 0. Let's say 0.6. Leave it like that. And let's do the same thing for man and woman. Let's do 0.5. The lion can stay 0.6. He is pretty heavy. And then we have speak. Yes, the king can speak. The queen can speak. The man can speak and the woman can speak. The lion can't. So as you can see, these are our vectors. This is our feature list, and these are the weights for each feature for each vector. So with that being said, let's move down. Now, if we compare this style of vector to our original vector, seen line 65, we will see that this style is a dense vector and it has more meaning as opposed to the one on 65, which is a sparse vector. You can see here it barely has any meaning and it's sparsely vectored. So you can see this is it here. Let's go back down. So this is a 5D vector. Let me show you why it's a 5D vector. So you can see here we have 5 dimensions: 1, 2, 3, 4, 5. That's our 5D vector. So now that we have so the way this works is that the weight of the features of our 5 vectors are passing to our neural network or are passing to the input layer, and then the input layer gets passed into the neural network's hidden layers, and the output vector of these are our embeddings. So let me break that down a little bit further for you. So you can see here we have our feature list here. This will get passed into our input layer. And if you've been following me, you should know what the input layers and hidden layers are by now. We've been going over it nonstop inside of the TensorFlow course, and we've been going over it nonstop inside of the math course that I took, even though I didn't really show you that much in the math course. It's something we've been going over nonstop in TensorFlow, so it should sound familiar to you. So with that being said, we have our feature list here that gets passed into the input layer. So what gets passed in, as you can see here, we have gender, and then we have all the weights of genders. So we have all of the weight of gender. We have this weight here, this weight, this weight, this weight, this weight. Now this entire gender here will get this entire gender feature will get passed into an input layer. This entire wealth feature will get passed into an input layer, and so on and so forth. That input layer will get passed into a hidden network or hidden layer, and that hidden layer will get passed into a hidden layer, and so on and so forth, determining how many specified by how many layers we have in our neural network, and then finally all of those layers will get passed into an output layer. And that output layer will produce one output layer that will look like this, which will be in vector form. And that vector would be our output layer, and that vector would be our embeddings. So that's what that would look like. So let's just imagine these were our hidden layers here, and this was our input layer. So our input layer would get passed into our hidden layers. Our hidden layers would get passed into one output layer that's in the form of a vector. So it'd be one vector, and that will be our embeddings. That's basically everything we went over tonight for the embeddings. We just wrapped it up as a simplified version of it, or a simplified understanding of the embeddings. Now, the next thing we're going to go over is why we need databases, or why we need vector databases. Over 80 to 85% of data out there is unstructured data. So, in the next or tomorrow, we're going to go over the reason why we need vector databases, and we're going to dive a little bit deeper. But of course, I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.